This is 7.3, Algebra 3. We're talking about statistics. This is going to be our discussion of inverse normal probabilities. So given a probability or percentage, we want to be able to work backwards and use inverse normal to calculate corresponding x values. Here are some guidelines for finding x values from normal distributions. Draw a bell curve. That's one of the first things we always want to do. Determine the probability or area under the curve, and then shade the region. Just as a quick little example, you're going to have some sort of shaded region. And that's going to be a probability, say 68% or 0.68, something like that. Obtain a z-score from the standard z-table that is the closest approximation to the probability. Use that z-score with the standard deviation and the mean to solve for x. That is if you have a z-table. Okay? Alternatively, we are going to use a graphing calculator or some sort of technology with the inverse normal function. Instead of using normal CDF, there's going to be a different function that is called inverse norm with parameters probability, comma mean, comma standard deviation, where that probability P represents the shaded area under the curve. So let's motivate with an example. The speed of vehicles along a stretch of the parkway are normally distributed with a mean of 58 miles per hour and a standard deviation of 4 miles per hour. At what speed or below do 90% of the cars travel at? So the probability that some speed should be equal to 0.9. And what we don't know is this number here. We're trying to find that number in miles per hour. Okay, so that's an unknown. We'll put a question mark there. We are trying to find that. So step number 1, draw your bell curve. The mean is 58 and the standard deviation is 4. So at what speed or below do 90% of the cars travel at? What that means is speed or below, that's less than or equal to. So we want everything to the left of that speed. That's our question mark, what we don't know. That's our x. But what we do know is that this shaded region should be equal to 90% or 0.9. So I'm going to go to the graphing calculator and then I'm going to put in inverse norm of 0.9 because that's the p-value, and then mean 58, standard deviation 4. So let's keep that in mind. So second distributions and you see our normal PDF and normal CDF that we've been using, the CDF. But we're going to go to inverse norm. And it says area. That's our P, or probability. So that will be 0.9. The mean is 58. The standard deviation is 4. And is our tail shaded to the left, at the center, or to the right? I think it's going to be to the left. And then paste. Alright, so now that tells us that this x value is 63.13 miles per hour. And that's our answer. Alright, let's give it a shot with the next one. The speed of vehicles along a stretch of the parkway are normally distributed with mean 58 miles per hour, standard deviation 4 miles per hour. Find the speed that 75% of the cars travel at or above. At this point, I would like you to pause the video. Please try the problem. Make sure to draw your bell curve, label the mean, the standard deviation, and then use the inverse normal function. Okay, go ahead. Alright, hopefully you tried it. Here's my curve. Mean 58, standard deviation 4. The trick is shading the correct region. Find the speed that 75% of the cars travel at or above. And that means that our x value should be greater than or equal to some unknown. The region to the right is going to be 0.75. Let's go to inverse norm of 0.75, comma 58, comma 4. Inverse norm, 0.75, 58, 4. But this time, I want the region to the right of that. So let's hit right and then paste. And I got an answer of 55.3 miles per hour. And that would be just below the mean. It makes perfect sense. I do want to point out one thing. I could also use the left part of the function, but just know that to the left here, that would be 0.25. So let's see if we can check our answer here. If I go back to the inverse norm, and I write 0.25, but choose to the left, and it comes out to be the exact same answer. So it's all about how you draw your bell curve and just making sure that you set up the question in the correct way. Please comment on this video in order to earn credit, and then have a nice day.